Hey guys, today's lesson is about mutations. We're going to be focusing mostly on chromosomal mutations for this one. We will touch on gene mutations a little bit towards the end, but we're going to come back to gene mutations in a later lesson. So for now, the chromosomal mutations are the important part. Okay, so in this mutations lesson, we're going to be looking at the difference between gene and chromosomal mutations. We'll also look at the different types of mutations that can happen during crossing over. Probably the most important type of mutation that we're going to be talking about in today's lesson is the type called non-disjunction. So you need to know what non-disjunction is and where during meiosis that would happen, as well as what the results of non-disjunction would be. Then we're briefly going to look at the difference between monosomy and trisomy, and then we're going to look at some gene mutations. So like we've talked about before, a mutation is just a random change in DNA, and the two main kind of overarching categories are chromosomal mutations and gene mutations. Chromosomal mutations are when the number of chromosomes or the shape of the chromosome changes, and this can be caused by a mistake in division, either mitosis or meiosis. Gene mutations are when the DNA itself is damaged within a gene. Usually this happens during DNA replication, which takes place in the S part of interphase, or when the DNA is damaged from external mutagens like chemicals or radiation and stuff like that. So chromosomal mutations can happen during crossing over. So if you remember, crossing over is when you have the tetrad form of the homologous pairs, and then two of the non-homologous sister chromatids kind of touch each other and swap some alleles. And there are kind of a couple different things that can happen if that swapping of alleles doesn't go correctly. So you could end up with a duplication. Essentially, this is when during what should be a swap, one of the sister chromatids gives up its allele like it's supposed to, and the other one doesn't. So one of these sister chromatids will have a missing segment, and the other sister chromatid will have a duplication. So duplication would be the sister chromatid that kept her own alleles plus took the other sister chromatid's alleles. Deletion would be the sister chromatid that gave up her alleles and didn't get any in return. You can also have an inversion where during that crossing over, the alleles get put in upside down from where they should be. You can have an insertion where crossing over happens between non-homologous chromosomes. And you can have a translocation where the section of alleles gets put into the wrong spot on the homologous chromosome. Okay. And there's examples of all of those across the bottom there. So a duplication, you end up with twice as many of that segment of alleles as you should. An inversion, the alleles get put in upside down. A deletion, where you're missing the segment of alleles because you didn't get it from your sister chromatid partner. An insertion, where non-homologous chromosomes cross over and switch alleles that shouldn't be switched. And then a translocation, where you've got a section of alleles getting put into the wrong place in a chromosome. So those are a type of chromosomal mutation. Knowing those specific types isn't super important. Knowing that you can have chromosomal mutations take place in crossing over is kind of the more important part. This type of chromosomal mutation, the type that happens during anaphase, is the one type of chromosomal mutation that you're going to want to know in a fair amount of depth. So non-disjunction is the type of chromosomal mutation that happens when chromosomes don't separate properly during anaphase. And this can happen in the anaphase of mitosis, when the sister chromatids are separating, or it can happen during anaphase 1 of meiosis, where homologous pairs are separating, or it can happen during anaphase 2 of meiosis, where once again sister chromatids are separating. All of that separation, whether you're separating sister chromatids or homologous pairs, that separation is sometimes referred to as segregation. So sometimes it's stated that non-disjunction is when segregation goes wrong. Aneuploidy is the result of non-disjunction, and you end up with having an abnormal number of chromosomes. So if non-disjunction happens in anaphase 1 of meiosis, then half of the gametes are going to have an extra chromosome and half of the gametes are going to be missing a chromosome. We represent an extra chromosome as N+1 and a missing chromosome is N-1. If non-disjunction happens during anaphase 2 of meiosis, then 2 of the gametes will be normal, 1 will have an extra chromosome, and 1 will have a missing chromosome. And this is the reason for that. So on the left-hand side here, we have non-disjunction, so the failure of segregation, essentially, happening in meiosis 1. So in this cell here, the homologous pairs should be separating. The homologous pairs on top are segregating properly. The homologous pairs on bottom are not separating properly, so that's the non-disjunction. What that will mean is that the only chromosomes that go to this cell here are these two right here. Well, it's actually just a single double-stranded chromosome, which will become 2 single-stranded chromosomes. All of these guys, all of these chromosomes, all 3 of the double-stranded chromosomes are going to go to this cell where the sister chromatids are then separated. So that is why half of the cells, half of the resulting gametes end up with an extra chromosome and half of them end up missing a chromosome. Now in the second example here, the non-disjunction doesn't happen until meiosis 1, which means that this cell on the far right here is still normal and it's dividing normally. So the 2 gametes that result from that cell, these 2 gametes down here, are both completely normal. This cell is the one that's not dividing properly. It has the non-disjunction taking place. And so one of its resulting gametes will have an extra chromosome and one will be missing a chromosome. Aneuploidy is just the way that we say that a gamete with an abnormal number of chromosomes is fertilized to produce a zygote with an abnormal number of chromosomes. So as soon as we have a zygote with an abnormal number of chromosomes, we refer to that as aneuploidy. This does happen fairly common in humans. It does usually result in a miscarriage very early on in the pregnancy, but there are certain types of aneuploidy that are not fatal to the embryo. And if that's the case, then that embryo will develop into a fetus and into a baby, and then that baby will be born with some sort of syndrome or symptoms caused by that abnormal number of chromosomes. Having an abnormal number of chromosomes will always have some sort of symptoms attached to it. If the aneuploidy is the type where that individual has an extra chromosomes, that's called trisomy. So trisomy means that you have 3 copies of one of your chromosomes. You would still just have 2 copies of all the other ones, but one of your chromosomes would have an extra copy. And the syndrome that that person would have would depend on which chromosome has that extra copy. And then monosomy is the type of aneuploidy where the individual is missing a chromosome. So all of their chromosomes are in pairs except for one that's by itself. So some common examples that you guys do need to be familiar with is Down syndrome, Turner syndrome, and Klinefelter syndrome. Down syndrome is also called trisomy 21. It's when there is 3 copies of the 21st chromosome. The symptoms include delayed physical and mental development. There are kind of characteristic facial features like widespread eyes. There's increased risk of heart defects, that kind of thing. And the risk of having a baby with Down syndrome does increase with the mother's age. Turner syndrome is a type of monosomy where the X chromosome does not have a homologous pair, so there's only one X. This will result in a female that does not develop her secondary sex characteristics normally and is likely sterile, so unable to produce children. And then Klinefelter syndrome is a type of trisomy where there is an extra X chromosome in a male, so he would be XXY. This results in a male that will have some secondary female sex characteristics, like maybe wider hips or slight development of breasts. Will also have underdeveloped male sex traits, so tends to have a higher pitched voice and less facial and body hair. This male will also be sterile. And then you should also be able to identify anything that is referred to as trisomy whatever. So if it's trisomy 3, they'll have 3 of the 3rd chromosome. Trisomy X would be 3 X chromosomes, stuff like that. And all of these types of aneuploidy are diagnosed using karyotypes. And then polyploidy is when you have an extra pair of every chromosome. This is referred to as like 3N would be 1 extra pair of every chromosome, 4N would be 2 extra pairs of every chromosome. This doesn't happen in humans, but it does happen fairly frequently in plants. These plants usually have larger flowers and fruit. In watermelon, we actually force non-disjunction to happen in order to make trisomy watermelons, which are seedless. The normal seed watermelons are diploid. Okay, so that's it for chromosomal mutations. We're now going to quickly run through some different gene mutations, which is when the mutation happens within a gene. And again, we're going to talk more about this later on in this unit. But for now, what you need to know is that each gene is made up of codons, which are groups of 3 nucleotides in a specific sequence. So that's why this example here, in this example, the sentence, the cat saw the dog, represents the gene, and each 3-letter word is a codon. And then each letter is a nucleotide because codons are made up of 3 nucleotides. Usually this type of mutation happens during DNA replication if it's happening naturally. So you might have a point mutation where 1 nucleotide is just swapped out for another, or in the case of this example, 1 letter is just swapped out for another. A frame shift mutation is when you have either an insertion where an extra letter or nucleotide is inserted, or a deletion where a nucleotide or letter is removed. And if that happens, all of the letters shift over 1 spot. If you've added in an extra letter, it'll shift over 1 way. If you remove a letter, it'll shift over the other way. And as you can see based on these examples, when you do that, the sentence becomes much more illegible than with a simple point mutation, where usually the sentence changes but is still legible. The frame shift mutations are much more damaging to the entire gene. You can also have an inversion where a codon is flipped backwards, a duplication where a codon is duplicated, or a translocation where the codon is moved to the wrong location. Of those different types of gene mutations, the 2 that you should be familiar with are point mutations and then the 2 different types of frame shift mutation. I don't really care if you know inversion, duplication, and translocation. The effects of gene mutations. Point mutations will sometimes not have any effect on the individual because sometimes two codons actually mean the same thing. Gene mutations can also sometimes be beneficial, which is how new traits evolve. And then other times they can be harmful or lethal because the gene can stop working. That's especially true for our frameshift mutations. They're much more likely to be harmful or lethal. Again, don't worry about this for now. We're going to come back to these kind of specific amino acids and stuff like that in a later lesson, in the second half of this unit. Okay, I would recommend, just as a little bit of practice with your karyotyping, that you go to this website here. And what it's going to do is it's going to give you an example of some karyotypes. You can determine the patient's gender from those karyotypes and also diagnose their condition if they have one based on any abnormal amounts of chromosomes. So try that out. On a tester quiz, you could very well get an example of a karyotype and be asked to identify gender or any disorders that are present. So that is good practice. Okay, and that's all. Let me know if you have any questions.